What should we deal with first? Or what should we do?
The inside parentheses.
Rob, yeah, hold on.
You make everything smaller, so you distribute it.
Distribute what where?
I would first distribute that negative sign.
Yep.
2x and then.
Yeah, so I like that. Start in the middle. Start in the middle. So 2x minus what? 4 plus 3 equals, and can we distribute on the right hand side? Is that okay? Yeah. 2x plus 2. What can we simplify now? Someone else. What can we simplify now? Someone else. Chris. Yeah, so you have it. 2x minus 4x minus 8 plus 6 is equal to 2x plus 2. Now what do I do? Someone new. Yeah, go ahead, Gabby.
Can you subtract 8 from 6?
No, you could. Yeah, so yeah, you can combine like 2. You can combine like terms. So what's that going to become? Minus 2. Sure. What do these two become? Negative 2x. So it's going to be minus 2x minus 2 is equal to 2x plus 2. Now what should I do to both sides? What could I add to both sides? Rob?
You can add 2 and then subtract 2x.
Let's add 2 to both sides. And let's add 2x to both sides, actually. Let's just do this. Keep it positive. So what are we left with on the left? 0. Because equals, how many x's over here? Nope. 4x plus what? 4. Now what should I subtract from both sides? 4. So minus 4 is equal to 4x. Divide both sides by? Divide both sides by 4, and you get x is equal to negative what? There it is. If I look first, what should I do? Inner parentheses. So we could, on the left here, we could distribute right here. So you have negative 3x minus 2x minus 5 equals negative 4 minus, let's distribute here first, right?
Yeah.
So that's not 3, it's going to be what?
6x.
6x minus 12 minus 3x, like that?
Yeah.
Can we combine? Oh, we get negative, oh, we get, how many x's right here?
2,
Just
3, 5.
No, there's 1 x. 2 through 5. None of those are actually. I like the energy. Minus, and what do you get? You get 6x minus 3x. How many x's is that? 3x minus 12. So then you get negative x plus 5 equals negative 4 minus 3x plus 12, right? What should I add to both sides? What's something I could add to both sides?
4.
How about I add 3x? You could. Let's add 3x too. Let's add 3x. So what do we, and then maybe, what next? So let's just, what do we get? 5 equals, let's just do one thing at a time, I guess. Oh, it's 2x plus 5, right?
Yeah.
Equals negative 4 plus 12. What's negative 4 plus 12?
8.
I can say 8. So now what should I subtract from both sides?
5.
Let's go to blue here. Minus 5, minus 5. We end up with what? 2x equals 3. It's 8 minus 5 is 3. So x is equal to what? 3 over? 3 over 2. 3 2s. So not quite. Yeah, okay. So I think we talked about one similar to this one. So on number 3 here, what's it asking you to solve for? What's it asking you to solve for? It's on for L, right? So you're taking this thing. P is equal to 2L plus 2W. And which one are you solving for? Solve means you're isolating it. So if I want to isolate it, what do I have to subtract first? So P minus 2W is equal to 2L. But we want L isolated, so what do we have to divide by? Not subtract, divide. So what is this going to be? P minus 2W over what?
2
Equals?
L.
Done. Wanted to? You could write this as P over 2 minus 2W over 2 is equal to L. And that would be P over 2 minus W equals L. But you have to make sure the P is also being divided by 2. You can't divide one thing by it. Like A plus B over C, that's equal to A over C plus B over C. You have to do both of them. So a number, the product of 8 and 16 less than a number. The product of 8 and 16 less than a number. So what does product mean? So the product of 8 and 16 less than a number. How do you write 16 less than a number? X minus 16. 16 less than, this right here is a number, right? This is 16 less. So what about this one? The quotient of 3 times a number and 10. The quotient of 3 times a number and the quotient of the number and 10. That's it. Yep. It says Jennifer Siegel invested some money at 4% simple interest and $1,000 less than twice this amount at 3. Her total annual income from interest was $1020. How much was invested in each rate? So she's investing money into 2 accounts. The first thing you do is you read the question and then you come up with what you need to know in order to answer it. So it's how much was invested at each rate. How many different accounts are there?
2.
There's 2 accounts. So what's one of the accounts?
3%.
And the other one's at 4 and at 4.5%, right? So how many variables do we need? 2. So let's say X is amount invested at which rate? 4.5%. And what's Y going to be?
Same.
Amount interest at what?
3.
3%. What do you know about so Jennifer Siegel invested some money at 4% simple interest and $1,000 less than twice this amount at 3%. So can you tell me $1,000 less than twice this amount?
So something about like Y minus $1,000 or something.
So she invested some money at 4.5%. That's X, right? And she invested $1,000 less than twice that amount at 3%. So Y is the amount at 3%. So $1,000 less than twice this amount at 3%. So Y is going to be equal to $1,000 less than twice what? 2X. X is the amount that you're investing at 4.5, right? Jennifer Siegel invested some money at 4.5 and $1,000 less than that at 3%. Twice that. So what does $1,000 less mean? Minus 1,000. 2X is twice this amount. That's the 4.5. So this is $1,000 less than twice. So we know that Y is equal to 2X. So we have one equation so far. Is that enough? No, it's not. Her total annual income from the interest was $1,020. Her total annual income from the interest was $1,000. Now, when you're dealing with interest, let's say I said there's $100 in your account and you earned 5% interest. How much money did you earn in interest? How much money? Percent is not money. $5. How did you get $5? What did you multiply? 5% of 100. So what mathematical operation is that? That's 100 times 0.05. Exactly. So the amount of money, the interest you earn is equal to the money you have in the account times the interest rate. What does X represent? What does X represent?
4.5.
The amount of money invested at 4.5%. Use a complete sentence. What does Y represent?
The amount of money interested at
3%. Right. Okay, so how much in terms of X and 4.5%, how much interest does this account earn right here? So the interest in the X account is going to be X times what? With them first. Add them. So you know that X times 0.045 plus Y times 0.03 is going to equal what? Exactly. So how many equations? You can sit down now, everybody. How many equations do you now have? One equation there, and? So again, how many equations do we have? 2 equations. So we did this several times yesterday. What do you do now that you have 2 equations? Chris? Yeah, you already have Y as isolated, so take this one up top, and what do you do with it? Substitute it in there. So what is that going to look like when I do that substitution? Instead of Y, what do I write? Yeah. So you get 0.045 plus Y, what is it? 2X minus 1,000 times 0.03 is equal to what? 1,020. You can use your calculator, solve for X now because you have one equation in one variable. Use your calculator and solve for X. 0. What? 105 X equals, and what do you do to, you add 30. So So you get 1050. Now what do you divide both sides by? 0.105. So what does x equal? What's it equal? It's not a rhetorical question. Need some help. Use your calculator right now for me, please. 10,000. Correct. It's 10,000. Now we have x, but are we done answering this question? We have x. What do we need to find? Well, what do we know y equals? 2x minus 1,000. We know that y is equal to 2x minus 1,000. So that's going to be 2 times 10,000 minus what? 1,000. So that's going to be what? 19,000. So that's how much in one account, and that's how much is in the other. There it is. 2b squared. Is the 2 being squared? No, it's not. So for example,
b was 2, you do.
That's what it equals. 2 times b times b. So if b was what?
b was 2.
So it would be 2 times 2 times 2 is 8.
Yes.
Because look. 2b squared is not the same thing as 2b like that. You see the difference?
Yeah.
Yeah. So if it was
If you put the 2 in there, what's 2 times 2? What's 2 times 2?
4.
What's 4 squared?
16.
2 times 2 times 2 is 8. These are not the same thing.
Okay, so you would do.
The square on b and then 2.
Okay. Yes.
Yes, Chris.
Would it matter if I put it in parentheses?
Yes, if you added. If you what?
Put the b in parentheses. Would that
If you
matter?
put the b squared in parentheses?
No, just
Did you get 8?
Yeah.
Then you're fine. There's lots of ways you can add in parentheses properly. I'd have to look at your sheet to know if it's done. Okay, so here's the thing. We need to make sure you practice word problems. It just takes practice. If you don't put in the time, they will go poorly. If you put in the time, it will get better. I guarantee it. Just like with any complicated or larger set of words or math problem, whatever you want to call it, do it piece by piece. Do it piece by piece. Verdi, Gabby, please put your surfaces flat. Thank you. So the first thing is read the problem several times if necessary. And then we already talked about this. What are we looking for? One of the questions we just did, it was how much money goes into each account. Then assign a variable, then write an equation. You see these first three? Don't try to do them all at once. Then you solve, then you state the answer. Actually, tell me what the answer is. And then check if you have time. Check if you have time. Make sure it makes realistic sense. So let's try this one right here. It says, for a bill totaling $5.65, a cashier received 25 coins consisting of nickels and quarters. How much is a nickel worth? Just so we can make sure everybody knows. 5 cents. If you're not from the United States, sometimes you don't know because you don't really use them that often. How many of each denomination of coin did each cashier receive? So what's the first step? We read it. What are we trying to find to answer this question? How many nickels? How, literally you write this down, how many quarters? So how many variables do we have? So what do we want how many nickels to be? What letter? N. Use something logical. What about quarters? Q. What's the first equation we can write? Hint.
Coins plus nickels equals.
N plus 2.
Yes. N, you guys said the same thing, but say that you said the same thing. It's fine. But N plus Q is what? 25. How many equations do we now have? Just one. How many do we need? 2. So we need one for the value. We haven't used this yet. How do you come up with the next equation? How do you come up with the next equation? Times what? And what does that have to equal? Nope. 565. If you're ever lost for how to come up with the next equation, look at what information you've already used. If you've used 25, you're not going to use it again. If you do, you'll do this sometimes. You'll use the same information twice, and when you go to solve, you're going to get an answer like this: 7 equals 7. And you're like, that doesn't help me, right? So we used all the information. Hey, how many equations do we have? Yay! How many variables? 2. So if we want to solve this, this is almost identical in structure to the one we just did. Almost, right? What's the only thing we need to do first? We're looking to substitute, but what do we need to do first, Hannah?
We have to get one of the variables.
Yeah, so which one do you want to look at, the top row or the bottom row? Let's look at the top. What do you want to isolate on the top, Hannah? N. So in this case, what is N going to be? 25 minus what? q. You subtracted q from both sides. Now, where do we plug that in, Gabby?
Into where then.
Yeah, you take this and you go whoop, right there. So instead of n, what do we write? Q. And is everything else the same? I'm writing this backwards, which is kind of hard. I'm going to commentate my life. Okay. Hey, how many equations do we now have? We just have one equation and one variable. Does that make us, is that good? Yeah. What are you going to need generally to do this one? It might help to use your calculator. Now, here's another question. What types of numbers should we expect to get for the number of quarters and the number of nickels? What kind of numbers? Whole numbers, right? You understand? If you get an answer like 4.7 nickels, something should be wrong, right? You're like, man, I got to go get me like an arc welder to cut this nickel, right? So you would use a calculator on this, but you would need to clean it up first a little bit, right? Do you feel confident that you could solve that? The practice, everybody, where do you think the hardest part is right here? Which part here was the hardest part, do you think, the most challenging? Writing which equation? The second one. Usually one equation is a little bit harder to write than the other. If you try to write it all at once, it will fall apart. Because here's the thing. If you can't do it for the easy ones, it's going to be really, really hard to do it. You have to do it piece by piece. So are you okay figuring this one out by yourself? So you would get Q, and then once you get Q, what do you do with that number? Right there, and what would you get? N. Do these piece by piece. Keep track of what information you've used. Okay, let's keep going. Nice. Westbound. Excellent. That's very good. Fantastic. So you have a picture of what's going on. Now, do you understand what it's asking? What's the question asking?
When are they going to be 300 miles apart?
Excellent. So we need to write an equation for the distance they are what? The distance they are apart. it's not a. There you go. Look, I like this picture. This is really good. Yay. Woo. It's now in the class notes. Excellent. Okay, so we need to write an equation for distance. What is the equation we're going to use to calculate distance traveled? Oh, come on. Not asking you. Come on, guys. Distance equals rate times time. I can guarantee you've all used that before. Really? Really? You've never seen distance as rate times time? I'm sorry. Okay. Excellent. Okay. My apologies. Distance is rate times time. So we have the blue car here. Both cars are starting at the same time, right? So they're going to travel the same amount of time each. Are you okay with that? So how far does this westbound car go? What's the rate of the car? 50. Do we know how long it's traveling? No, so we're going to call that T. What about the eastbound car? Distance for the eastbound is going to be what? Times what? T. So we have the distance the westbound car is traveling and distance the eastbound car is traveling. We want the total distance to be what? So what do we do with those two things? Add them together. So 50t plus what? Is going to be equal to? Hey, is that straightforward? Yeah. 90t equals 300. So what does t equal? 300 over, which is 30 over 9, which is what? 10 over 3. That's in time, right? 10 over 3. So how many hours is that? How many hours is that, Gabby? It's 3 2/3 hours. So give me that in real time. So that's 3 hours and how many minutes? 20 minutes. Excellent. Take a look at this. How do you feel about what's on the board right now? What do you think? I didn't even put the question. What do you think the question is asking? Find x. What's the relationship between all the internal angles of a triangle? They not all equal. They all together, all added together. So solve for x for me. You don't need a calculator. Solve for x. So it's going to be x plus 20 plus what? 210 minus 3x. And what's that equal? Yeah. So you have x plus 20 plus 210 minus 3x. 220. You have 2x minus 3x, so minus what?
230.
Oh, I can't add. Thank you. That's exactly the kind of thing you need to get me on. 230 minus equals 180. So minus x equals minus 50. So what does x equal? 50. Who got 50?
Yeah.
Couple? Nice.
How did you